So we're trying to prove the identity for what the integral of cosine the nth power x dx is. So first thing we can do is rewrite this as the integral of the cosine of x times the cosine of n minus 1 to the x dx. And this can be integrated using integration by parts. So I'm going to let u equal cosine of negative 1, or I'm sorry, cosine of n minus 1 x, and this means that du will be equal to n minus 1 times the cosine of n minus 2 to the x times negative sine of x by the chain rule. And since we're using integration by parts, I'm going to let dv be equal to cosine x dx, and this means that v must be equal to sine of x dx. And so by integration by parts, this integral must equal, well, the u times v, so it'll be cosine of n minus 1 to the x, cosine of x to the n minus 1, times the sine of x, minus the integral of v du. So in this case, that will be negative sine squared x times the constant n minus 1 times the cosine of n minus 2 to the x dx. And I'm going to clean this up a little bit. So we've got the cosine of n minus 1 to the x times the sine of x plus n minus 1 times the integral of, recall that sine squared x is equivalent to 1 minus cosine squared x. That's times cosine of n minus 2 to the x dx. And if I keep going with this, I've got cosine n minus 1 to the x, sine of x plus n minus 1 times the integral. When I distribute cosine of n minus 2 back in, I'll get cosine of x to the n minus 2 power minus cosine to the nth power of x dx. I'm going to break my current integral up into two component parts, and then we'll be able to show the identity. So rewriting the whole thing, I've got the cosine of n minus 1 to the x times the sine of x plus n minus 1 times the integral of cosine n minus 2 to the x, and this is minus n minus 1 of the integral of cosine to the nth power of x dx. And here's the key. is remember that where we are in our work, all of this is just a simplified form. We've just simplified down cosine x to the nth power, right? So if I had an equation, this is my left-hand side, and this is my right-hand side, which means I can add this component to the other side. So I'm going to add n minus 1 of the integral of cosine n to the x dx back to the other side. And my other side has one of those integrals. So 1 plus n minus 1 leaves me with just n. I'll have an equation, n times the integral of cosine n to the x dx equals cosine n minus 1 to the of x sine of x plus n minus 1 times the integral of cosine of x to the n minus 2 power dx. And if I divide both sides by n, then what I want to know, this integral, cosine of n to the x dx equals everything divided by n, or specifically cosine of x to the n minus 1 times sine of x, all divided by n, plus n minus 1 divided by n times the integral of cosine n minus 2 to the x dx. We've now proven this identity, and we can use it for any value of n.